Today's lesson is Lesson 1.2, Integers and Absolute Value, and we're going to start by watching a video.
If you're like us, this has probably happened to you. There you are, sitting in your room, avoiding homework, scrolling through YouTube channels, wondering which video to watch next. Ooh, Epic Rap Battles History. Wait, tell me if the Cooley has a new video. Click it!
No. I saw the paint drying one, we're watching that one.
Paint drying?
Yeah, trust me, just click it.
Suddenly, in the midst of your procrastination, your parents say something like,
Grace, 5 more minutes and you and your math friends gotta do your homework. She's always on that internet. I swear those videos are gonna rush.
Real Housewives is on.
okay, so now we only have time to watch one more video.
Yeah, but which one? No,
Try it.
Harrison Ford one. He
Try it.
literally points at stuff.
Relax! Integers are going to help us decide which video to watch next.
That's right. If you're a regular YouTube viewer like us, you've been using integers to make shrewd viewing decisions.
Where are the integers? Well, underneath the play count, there's 2 numbers. There's the positive votes, then there's the negative votes on the other side. Those positive and negative votes are positive and negative integers. YouTube just didn't put the positive and negative signs next to the number. Yep, that's what integers are. Whole numbers, like 1, 2, or 38,000 we saw. The negatives of whole numbers, like -1, -2, -20, which we saw earlier. And then there's 0.
Integers are not fractions, decimals, or percents. So numbers like 1/6 or -200% or -1000 don't qualify.
Yes! Just makes things a lot easier, guys.
You remember that one time when you went to the mall with your friend Shauna and you didn't have any money, so she lent you $50 and you bought this really cute denim jacket? But owing your friend $50, that's a negative number. One that I promised to pay back very shortly. Shauna?
Now that we have talked about integers, let's see how we write them down on a number line. Positive numbers go to the right of 0. You can write them with or without the positive sign. They mean the same thing. 3 is the same thing as positive 3. Just don't call it plus 3 because math teachers don't like it. It's an operation.
Negative numbers go to the left of 0. And yes, that is a negative sign, not a minus sign.
Seeing integers on a number line helps to understand the value of one integer compared to another. As we move to the right on the number line, numbers increase in value. For instance, -5 has a greater value than -16.
But if we move left on the number line, numbers decrease in value. After all, would you rather watch a video with 20 thumbs down or one with just 2 thumbs down?
Are you talking about my paint drying video?
Maybe.
Okay, now that we've talked about value, let's ask a question. Which integer has a greater value? -5 or 4? First, we put -5 and 4 on a number line. We see that 4 is farther to the right than -5. Let's also place a positive sign in front of the 4. That's a nice trick as well. Still stuck? Think about 2 YouTube videos. One has -5 votes and one of them has 4 positive votes. Which one would you choose? Okay, so the answer is positive 4 has a greater value than -5. Pac-Man loves positivity.
Yes, he does. Okay, want to play around with positive and negative numbers? Hit the thumbs up or thumbs down on our site.
And if you leave some comments, positive or negative, they'll be very much appreciated.
Oh yeah, and one other thing. The next time your parents say,
Grace, are you watching those YouTube videos again?
just say, relax, I'm working with integers! And then go back to watching Math Club.
If you want to play around with integers, stick around for the quiz.
So let's look at our first example. The Global Positioning System, GPS, can be used to determine elevations. The table shows the lowest elevations of several countries. Which country in the table has the lowest elevation? So instantly you can look at that and see it, but if we graph them on a number line, you can see that the one that's farthest to the left is the lowest. So as most of you have probably noticed, it was the -154 meters, which was China's. Okay, let's take a look. So in this example, we're going to order the integers from least to greatest. So one technique you can do is to graph them on a number line. Okay, so if I put 0 here in the middle, I have a -7, I have a 2, a -1, a -2. All right, and then I can kind of see that I would put them in order least to greatest: -7, -2, -1, 0, and 2. Okay, try another one. Okay, so in order from least to greatest would be -11, -4, -1, 9, and 12. Let's try one more. And in least to greatest order, it would be -99, -60, 0, 16, and 44. To find the absolute value, this is another thing we need to review at the beginning. This problem says, an eyeglass prescription is given as a positive or negative number. A prescription for a person who is farsighted is positive. A prescription for a person who is nearsighted is negative. The greater the absolute value, the stronger the prescription. So which prescription is stronger? So this brings up the topic of absolute value. So the definition of absolute value is the distance from 0. So when you look at these two numbers, you can see the symbols for absolute value are the straight, almost like field goal looking symbols around that -3, and the value of that is how far it is from 0. So -3 is 3 units from 0, 2 is 2 units from 0, and so now we're just comparing the 3 and the 2. Since the 3 is greater than 2, the prescription of -3 is a stronger prescription. Okay, what about opposites? So any number plus its opposite will be equal to 0. Okay, so let's look at 5. So it says write the opposite of the integer. So if you are given the number 5 and you're asked to write the opposite, we want the number that added to that would be equal to 0. Okay, so the opposite of 5 would then be -5, because 5 plus -5 equals 0. If I start with the integer -12, its opposite would take me back to 0 and would have to be going in the positive direction, so it would be +12. So the opposite of -12 is a +12. When you bring in the absolute value symbols, you have to first evaluate the absolute value. So in C, it's asking for what is the opposite of the absolute value of -9. Since the absolute value of -9 is 9, the opposite of that would be -9. Okay? Because the absolute value of -9 is 9, the opposite of the absolute value of -9 is -9. Does that make sense? Okay, in this example, we're going to write the absolute value and the opposite of the integer I give you. So for -16, the absolute value of -16 is 16, because it's 16 units from 0, and the opposite of -16 is also a +16. So somehow when you're doing this on a test or an assessment, or you have to indicate which one is which. So if you want to abbreviate for opposite and use the letter O, that's fine. You know, absolute value and put AV, that's fine. For number 5, and 140, the opposite of 140 is -140, and the absolute value of 140 is 140, because it is 140 units from 0. And -1. The opposite of -1 is 1, because -1 plus 1 equals 0. And the absolute value of -1 is a +1, because it is 1 unit from 0. And 0. Tricky. The opposite of 0 is 0, and the absolute value is also 0, because it is 0 units away from itself. All right. So if we're going to simplify these next numbers here, for A, we have basically a negative symbol, which we can read as the opposite of. So we're asking for the opposite of the absolute value of 9. So first evaluate the absolute value of 9, and then bring in the opposite sign. So the opposite of the absolute value of 9 is negative 9. Because the symbols around the number 9 are parentheses and not absolute value symbols, this is just asking for the opposite of 9, so negative 9. We have multiple grouping symbols here. There are no absolute value symbols. And when you have multiple grouping symbols, one trick that you can look at is if there is an odd number of negative signs or opposite signs, then the answer will be negative. If there is an even number, then it would be positive. So we start in the very innermost and we have negative 9. Moving out, we want the opposite of that, which is 9. And then we want the opposite of 9, which then again is negative 9. It's like a pattern. So now we want the opposite of the absolute value of negative 9. Anything in the absolute value symbols, remember, is talking about distance from 0. Negative 9 is 9 units away. So again, it's very similar to A because we want a negative 9 as our answer. And finally, the opposite of negative 9, again, there's only 2 symbols, no absolute value symbols, right? 2 negatives, no absolute value. So it's an even number of negatives, makes it a positive 9. Okay, now we're going to evaluate if x is equal to negative 8. When we do these types of problems, I'm going to ask that you be really cautious with these negative signs and even kind of come in here and draw in a parentheses there because we have to kind of protect the number because this is the number we are going to drop in place of every variable x. So 5 plus, and then I have, guess I could do this. Right? Sometimes we make the other brackets. So now let's evaluate inside the parentheses. So we have the opposite of negative 8, which comes out of here as a positive 8. So 5 plus 8 is 13. Okay, again, so I have the opposite of negative 8 minus 1. So by putting in those parentheses around the x, I can see that that negative sign doesn't stand for the negative sign that is equal to or substituted in for the value of x, which gives me again a positive 8 minus 1 or 7. I guess I went a little too fast there. Let's look at this. If we have the absolute value of, interesting. So in this case, we're going to have, it works out either way. It works out the same because of the absolute value symbols. That's ironic. But if we have the absolute value here, right, we know, and this is an 8, we know that this is going to be 8 minus 1 equals 7, which works out to be the answer. So sorry about that, I jumped the gun, but in this case it worked out the same.